China just built 158 kilometers of highway without a single human behind the wheel. Not one driver, not one operator, sitting inside a cab. Just machines moving in perfect sync, guided by satellites and artificial intelligence, laying road faster and cleaner than any human crew ever has. And that is just one of 8 machines China has quietly built that are rewriting the rules of construction entirely. The same country that built the world's longest sea bridge, the fastest rail network on the planet, and skyscrapers that went from empty land to fully finished towers in record time, did not do any of that with brute force alone. Behind every one of those projects was a machine so advanced, so powerful, and so precise that it makes everything built before it look outdated. In this video, we are going through all 8 of them, and by the end, you will understand why engineers and governments around the world are paying very close attention right now. If you are new here, hit a quick like and subscribe. It genuinely helps. And now, let's get straight into it. Sanap 2000C, the road that built itself. In 2025, something happened that had never happened before in the entire history of construction. A fleet of 10 robotic vehicles lined up on an empty stretch of road in China and started building a highway. No drivers, no operators sitting inside the machines, no human hands on any controls, just robots working through the day, guided by satellites to centimeter-level accuracy and managed by artificial intelligence in real time. By the time they were done, they had laid 158 kilometers of smooth finished highway. The paver at the center of this fleet, the SYSAP 200C, could lay asphalt across a width of 19 meters in a single pass. To picture that, stand in the middle of a standard road and look left. Now look right. The machine covered all of that and more in one single sweep without stopping. The AI running the operation was not just steering the machines in a straight line. It was making hundreds of decisions every minute. Obstacle detected. The machine stops and reroutes. Temperature of the asphalt dropping. The system adjusts the laying speed. One machine falling slightly out of sync with the others, it corrects automatically. The whole fleet operated the way a well-trained human crew would, except faster, more consistent, and without ever needing a break. And here is the part that surprised even the engineers running the project. The quality of the finished road was not just equal to roads built the traditional way, it was better. The surface was smoother, more uniform, and laid to a more precise depth than what manual crews typically achieve. The machines did not just do the job, they improved on it. Think about what this actually means for the future of construction. Every major infrastructure project in the world relies on skilled operators, years of training, and long, dangerous shifts on heavy equipment. China just proved that all of that can be replaced, and replaced well. That is not a small shift. That is a fundamental change in how civilization builds itself, and it is already happening. Zhenhua 30, the crane that moves the ocean. Now picture a ship, not a regular cargo ship, but something the size of 3 football fields lined up end to end, almost 300 meters long, carrying a crew of 380 people, and capable of lifting the weight of over 8,000 cars in a single lift, without tipping, without shaking, with the kind of precision a surgeon would respect. That is the Zhenhua 30, the most powerful floating crane on the planet, built by a Chinese company called ZPMC. When you see it from a distance on the open ocean, it looks less like a piece of equipment and more like a floating city with a crane attached. So, what do you actually need something that powerful for? To answer that, you need to understand what it took to build the Hong Kong-Zhuhai-Macau Bridge, the longest sea crossing structure on Earth, stretching across open water for over 55 kilometers. This bridge includes a section that disappears underground and travels through a tunnel sitting on the actual ocean floor. Those tunnel sections did not build themselves. Someone had to lift each massive concrete piece, carry it out to sea, and lower it to the seabed with such precision that the gap between one section and the next was smaller than the width of your finger. A single miscalculation and the tunnel floods. The Zhenhua 30 was the machine that made that possible. It would grip a tunnel section, sail it out to the exact coordinates, and lower it into place using a system of sensors and computer controls that adjusted the lift in real time as the ocean moved beneath it. The margin of error was not a few centimi, it was millimi on the open sea. In 2025, the same crane completed China's first 10,000-ton offshore steel structure installation, lifting an entire wind farm platform and placing it into position in the open ocean. a machine that treats entire pieces of infrastructure the way most cranes treat a steel beam. Nothing else on Earth comes close to what this vessel can do. XCMG 120, the machine with legs. Most construction machines need flat, stable ground to function. Give them a steep slope, a narrow ravine, a flooded forest, or a mountain path with no road, and they are completely useless. The XCMG 120 was designed for exactly those places, the ones every other machine gives up on. It looks like a mechanical insect. 4 articulated legs, each one able to extend, compress, and pivot independently, letting the whole machine walk across terrain that would stop any wheeled or tracked vehicle. Slopes that would tip an excavator sideways. The ET-120 walks up without hesitation, ground so soft it swallows ordinary machines. The ET-120 spreads its weight across all 4 legs and keeps moving. Online, people call it the Steel Mantis, and the moment you see it picking its way across an impossible mountain slope, the name makes complete sense. But here is what makes this more than just a spectacular-looking machine. It was built for the worst moments. The earthquakes, landslides, wildfires, and collapsed buildings where getting heavy equipment to exactly the right place can mean the difference between a rescue and a recovery. In those situations, roads are often destroyed, hillsides are unstable, and the terrain is genuinely dangerous to work in. Standard equipment cannot reach those places. The ET-120 can. Its arm accepts interchangeable attachments. So, the same machine can dig through rubble, lift collapsed beams, cut down burning trees, blocking escape routes, drill through rock, crush debris, or deploy firefighting equipment, all without needing a different vehicle for each task. And because it is operated entirely by remote control, the human operator stays at a safe distance while the machine does the dangerous work. China has been deploying these in real disaster response operations, and the results speak for themselves. A machine that looks like it belongs in a science fiction film is already saving lives in the real world, in places no other machine can reach. TBM Jinghua, the machine beneath your feet. Here is something that genuinely should not be possible. You are walking the streets of Beijing. Millions of people are doing the same thing around you. Cars, buses, the noise and motion of one of the largest cities on Earth. And 150 m below your feet, a machine the size of a 5-story building is grinding through the earth, pushing forward through sand, water, and soft soil, advancing through the darkness without stopping. Nobody on the surface feels a thing. The machine is called Jinghua, a tunnel boring machine over 16 meters in diameter and 150 meters long, weighing 4,300 tons. Its job was to drill over 7 kilometers of tunnel directly beneath the heart of Beijing as part of a project to expand the city's East 6th Ring Road, one of its most critical transport arteries. The problem was the ground below Beijing. The soil is not solid rock that a drill can bite into cleanly. It is a shifting mixture of sand, underground water channels, and soft layers that compress and move when disturbed. Apply too much pressure, and the ground above starts to sink. Move too fast and the water-soaked layers collapse inward. Any mistake of any size would result in sinkholes opening up in the middle of a city where millions of people live and work. Jinghua had to navigate all of that perfectly. Its control systems monitored the ground pressure around the machine continuously, adjusting the cutter head speed and the support pressure inside the tunnel in real time, essentially balancing the earth around it like a surgeon managing a patient's vital signs during a procedure. Every millimeter of movement was tracked, logged, and corrected if it drifted even slightly from the planned path. It worked without a single incident on the surface. No cracks in the road above, no sinkholes, no disruption to the millions of people living their lives just above the operation. In its best month, Jinghua pushed forward over 500 meters. By the time it broke through to the other side, it had completed one of the most technically demanding tunneling operations ever attempted in an urban environment. Here is the part that adds a whole extra layer to this story. Just 20 years ago, China did not build these machines. They bought them from companies in Germany, Japan, and France, paying enormous prices and depending entirely on foreign technology for their underground infrastructure. Today, Chinese-made tunnel boring machines make up nearly 70% of the global market. They went from buyer to world leader in the time it takes a child to grow up. That kind of shift does not happen in any other industry at that speed. XCMG rotary drilling rig, the hole that holds everything up. Before any skyscraper rises, before any bridge gets its first beam, before any offshore wind platform gets lowered into the ocean, something has to happen underground. First, a hole has to be drilled deep into the earth, wide enough and strong enough to anchor everything that will be built above it. Get this wrong, and nothing built on top of it is safe. For the biggest projects on the planet, that means using the XCMG rotary drilling rig, the most powerful foundation drill in the world. This machine stands 42 meters tall, roughly the height of a 1-4-story building, and weighs 520 tons. Its drill can cut a hole 7.5 meters wide, which is large enough to park several cars side by side inside it, and it can go 190 meters deep. To put that depth into perspective, imagine a 60-story skyscraper. Now, flip it upside down and push it straight into the ground. That is how far this machine reaches. It has been used to build the foundations for some of Asia's tallest towers, the support piles for sea-crossing bridges, and the anchor bases for offshore wind farms that need to withstand ocean storms for decades without shifting. What used to require weeks of work with conventional drilling equipment, this machine can complete in days without compromising on the precision those projects demand. The rig uses a computer-controlled torque system that monitors the resistance of the ground in real time and automatically adjusts the drilling force to match what it is cutting through. Whether that is soft clay, dense sand, or solid rock layers, the operator manages the whole process from an enclosed cab with a digital display showing exactly what is happening at the drill tip 190 meters below. It has been exported to over 80 countries. The foundations of some of the most ambitious construction projects happening right now across Asia, the Middle East, and Africa were drilled using this machine. The modern world quite literally sits on top of what this rig makes possible. WK-75, the shovel that devours mountains. You have probably seen a standard yellow excavator on a road construction site near where you live. That machine weighs around 20 tons on a good day, can scoop out a cubic meter or two at a time, and takes months to do what the WK-75 does before lunch. The WK-75 is one of the largest electric mining shovels ever built. It stands nearly 24 meters tall, which puts it at the same height as a 7-story building. It weighs 2,000 tons. Its tracks, the things it actually moves around on, are taller than a fully grown adult standing upright. Everything about it is scaled up to a level that stops making intuitive sense the longer you look at it. Its bucket, the scoop at the end of its giant arm, holds 75 cubic meters of material per bite. That is roughly the volume of 2 full-size shipping containers scooped up and dumped in a single movement. It processes around 12,000 tons of rock and earth every single hour. In 1 month of continuous operation at a coal mine, this machine pulls 5 million tons of material out of the ground. It runs entirely on electricity and has the equivalent output of 50 car engines running at full power simultaneously. That electricity drives 2 separate motors, one for the digging arm and one for the rotation of the upper body, allowing it to dig and swing and dump in one continuous fluid motion that looks almost graceful for something that size. The WK-75 was built specifically for China's massive open-pit mining operations, where the scale of extraction required was simply beyond what any existing equipment could handle. Watching it work in real footage is genuinely disorienting, because your brain keeps trying to find something nearby that it can use as a reference point for the size, and everything nearby looks small. TESMI M5, the chain that never stops. Underneath the ground right now, there are gas pipelines keeping homes warm, power cables keeping hospitals running, and irrigation channels moving water to farmland that feeds millions of people. All of that had to be cut into the earth at some point, and cutting it means digging trenches, long, deep, perfectly straight trenches through whatever the ground happens to be. Most of the time the ground is workable clay, sand, loose soil. Standard trenching machines handle that without much trouble. But sometimes the ground is granite, dense volcanic rock, material so hard that conventional trenching equipment hits it and stops. That is where the TESMEC M5 comes in. This machine weighs 77 tons and looks at first glance like a very large tractor, but attached to it is a cutting chain several meters wide. The kind of chain you might picture on a chainsaw, but scaled up to the point where each individual cutting link is the size of a brick. That chain wraps around a large boom that the machine lowers into the ground and drags forward, grinding through rock with slow, relentless force. It operates at 440 horsepower, and its chain spins far more slowly than you would expect, much slower than a chainsaw. But speed is not the point. The point is torque, the twisting force applied to the rock at each cutting tooth, and that force is extraordinary, granite formations that would shatter conventional cutting equipment and send repair crews scrambling. The M5 grinds through without slowing down. A GPS guidance system keeps the machine cutting at the exact correct depth and direction at all times, automatically adjusting as the terrain changes, so the finished trench is perfectly consistent from start to finish. It barely moves fast enough to notice from a distance, but it never stops and it never gives up. And wherever it goes, it leaves behind a clean, straight trench ready for whatever needs to go inside it. CPG 550, the machine that laid a nation. China has the largest high-speed rail network on Earth. Over 48,000 kilometers of track connecting cities that used to be a full day's drive apart in under an hour by train. 20 years ago, almost none of that existed. Today, it is the backbone of how the country moves. That kind of expansion does not happen with teams of workers laying rails by hand. It happened because of machines like the CPG 500, a track-laying system that works like a railway factory on wheels and never stops moving. Here is what makes it different from anything that came before it. Traditional track-laying equipment works in stages. It places a section of rail, stops, repositions, places the next section, stops again. The CPG 500 does not stop. It lays rails and places the concrete sleepers they sit on at the same time in a continuous, unbroken process, advancing steadily along the route without pausing between placements. In a single work shift, it can install up to 2 kilometers of finished, ready-touse track. It works with individual rail sections up to 500 meters long, a length that was considered completely unworkable with older methods because of how difficult it is to handle and align steel rails that long. The CPG 500 manages it with a margin of error of just 10 millimeters across the entire run. It runs day and night, stops only for scheduled maintenance, and has been exported far beyond China's own rail projects. It has been used in Malaysia, Indonesia, and Serbia. And it laid the first railway line to fully circle the Taklamakan Desert in the Xinjiang region, one of the harshest and most remote environments on Earth, where building anything at all is a serious engineering challenge. It may not grab headlines the way a spider-legged rescue machine or a highway-building robot fleet does, but in terms of lasting impact on how billions of people move, work, and live, the CPG 500 may have done more than any other machine on this list. These 8 machines are not prototypes sitting in a lab somewhere waiting to be tested. They are already out in the world, already building, already drilling, already laying road and rail across some of the most challenging terrain on the planet. The highway that built itself, the crane that sets tunnel sections on the ocean floor, the walking excavator saving lives in places no road reaches, all of it is already real and already running. If this video showed you something you had genuinely never heard of before, a like and subscribe takes 2 seconds, and it helps more than you might think. Turn on notifications too, so you do not miss the next one. Here is what I want to leave you thinking about. If one of these 8 machines showed up in your country tomorrow and started working, which one do you think would have the biggest impact on daily life? Drop your answer in the comments below. China just built 158 kilometers of highway without a single human behind the wheel. Not one driver, not one operator, sitting inside a cab. Just machines moving in perfect sync, guided by satellites and artificial intelligence, laying road faster and cleaner than any human crew ever has. And that is just one of 8 machines China has quietly built that are rewriting the rules of construction entirely. The same country that built the world's longest sea bridge, the fastest rail network on the planet, and skyscrapers that went from empty land to fully finished towers in record time, did not do any of that with brute force alone. Behind every one of those projects was a machine so advanced, so powerful, and so precise that it makes everything built before it look outdated. In this video, we are going through all 8 of them, and by the end, you will understand why engineers and governments around the world are paying very close attention right now. If you are new here, hit a quick like and subscribe. It genuinely helps. And now, let's get straight into it. Sanap 2000C, the road that built itself. In 2025, something happened that had never happened before in the entire history of construction. A fleet of 10 robotic vehicles lined up on an empty stretch of road in China and started building a highway. No drivers, no operators sitting inside the machines, no human hands on any controls, just robots working through the day, guided by satellites to centimeter-level accuracy and managed by artificial intelligence in real time. By the time they were done, They had laid 158 kilometers of smooth finished highway. The paver at the center of this fleet, the SYSAP 200C, could lay asphalt across a width of 19 meters in a single pass. To picture that, stand in the middle of a standard road and look left. Now look right. The machine covered all of that and more in one single sweep without stopping. The AI running the operation was not just steering the machines in a straight line. It was making hundreds of decisions every minute. Obstacle detected. The machine stops and reroutes. Temperature of the asphalt dropping. The system adjusts the laying speed. One machine falling slightly out of sync with the others, it corrects automatically. The whole fleet operated the way a well-trained human crew would, except faster, more consistent, and without ever needing a break. And here is the part that surprised even the engineers running the project. The quality of the finished road was not just equal to roads built the traditional way, it was better. The surface was smoother, more uniform, and laid to a more precise depth than what manual crews typically achieve. The machines did not just do the job, they improved on it. Think about what this actually means for the future of construction. Every major infrastructure project in the world relies on skilled operators, years of training, and long, dangerous shifts on heavy equipment. China just proved that all of that can be replaced, and replaced well. That is not a small shift. That is a fundamental change in how civilization builds itself, and it is already happening. Genhua 30, the crane that moves the ocean. Now picture a ship, not a regular cargo ship, but something the size of 3 football fields lined up end to end, almost 300